Hello, welcome to this video. This is the first video on gravitational potential energy. Really, this is just a revision of GCSE and an introduction to the concept of gravitational potential energy as a negative value. So, you're probably familiar with GCSE, the concept of gravitational energy being given by the potential energy being equal to mgh. And that's all good. If we think about now a mass, let's say we've got a mass m sitting on the floor. Well, there it is on the floor. We want to lift it up. Let's put it up a top of a mountain or something up there. We could say, well, what's this gravitational potential energy? Its potential energy is, of course, if we put that, mgh. Right, I'm going to put some little arrows there now. We would say here, because we've lifted it up, it's moved through a height, it's gained some gravitational potential energy. So up here, doesn't matter what the value is, let's not worry about numbers at this stage. EPE is mgh, that's cool. And we go up a hill, it gains gravitational potential energy. As it comes back down here, let's say it rolls down a hill now, we could say it goes back to being 0. So there's my mass, and now my gravitational potential energy is 0 again. And we can do all sorts of calculations. We can work out how much energy is required to lift something up a hill. We can say what kinetic energy it would have as it came back down. We can work out how fast it's going, etc, etc. But what happens if this thing now falls down a hole? Has it now got 0 potential energy? Did it actually have some potential energy up here? What's going on? We can't just say, well, this is now new 0 and therefore this must have been some potential energy. Well, we could do, because it definitely had some potential energy here. But then it's still got potential energy here because it can still go further down. So if we just have to think about potential energy relative to a reference point. Now if this is positive potential energy up here, it's going to be negative potential energy. Now, in order to understand where this negative, to explain this negative a bit more clearly, we need to really think about what's going on. What we're doing to give this object as it goes up potential energy? Well, essentially we're moving against a force. Gravity, mg, is a vector, it's a force, and it's acting downwards. The height is a displacement, it's a vector, and it's acting upwards. So we could really change this and think, well, really what's going on here is this is a positive height. Okay, so this is going up, it's a positive height. This is coming down, it's a negative height, it's going with the force. Okay, and so really we can start to think about this in terms of vectors, but it's very simple, it's much simpler at this stage to say, well, what is that gravitational potential energy? And to define it, EP is the work done moving an object, a mass we should say, against a gravitational field. A gravitational field. With this in mind, we could say, well, cool. Everyone's happy now. If something moves against the field, if we put this arrow as being that direction only, then we have a positive potential energy because we're working against gravity. And if we go downwards, it's going to lose potential energy. So anything come down, it makes sense. As we move down, we lose gravitational potential energy. As we go up, we gain gravitational potential energy. It's not really very complicated. The only thing that really sort of messes people's heads up is when we say if we take 0 and move it somewhere more practical. You know, a long time ago people thought the Earth was the centre of the universe and blah blah blah. We know that's not the case anymore, so it seems a bit stupid to start saying that the single point on the entire universe where the gravitational potential energy is 0 is on the surface of Earth. And if we say that, well, we're going to say where on Earth? Should we do it London, Greenwich, or should we do it at the top of Everest, or should we do it down at sea level, or blah blah blah. It makes a lot more sense to take this, put it somewhere really practical at the back end of the universe. Okay, so now if we change this and say GPE, gravitational potential energy, is 0 at infinity. Then, once we got our head around this concept, once we've accepted this concept, then any work that's done moving a mass against the gravitational field gives a positive potential energy, but you can't actually do work against the gravitational field to infinity. But what you can do is you can go with a gravitational field. So if we now have a mass, let's take ourselves a massive object, I'm going to call this a big M, like a planet, like a star, like a whatever, at some infinite distance away at infinity. Okay, at infinity, the EP is 0. But if we move down to some sort of local orbit around our massive object, like, I don't know, a moon or something, doesn't matter what it is, but if we move down to some point here, we've basically gone with the gravitational field, we've moved towards it. Okay, so now the potential energy is going to be negative. Okay, and that's the first thing to get your head around. Once you get your head around that, everything else is quite straightforward. So we'll leave this video at this point here, and just let's just summarise what we can say here. When we move against the gravitational field, the potential energy of an object increases. When we move with a gravitational field, the potential energy of an object decreases. If we say the place it's got 0 energy is infinity, then anywhere inside a gravitational field, the potential energy of an object will be negative. But that doesn't change anything that we understand from GCSE or anything, because if you've got, let's say your potential energy here is minus 100 joules, as you move up to there, it's now going to be, let's say, minus 50 joules. The difference is, as you've moved up, is the difference is plus 50 joules. So it doesn't change anything at all in terms of our understanding of doing work to move against the gravitational field. We still put energy into a system to move it out. We get energy back out of systems as it comes down. The only difference is the place it originally had no energy was infinity, and anywhere in the field, inside the gravitational field, we'll say that potential energy is a negative value. So that's that for now, and in the next video we'll look at why that's the case, and we'll look at a formula to explain.